So now we're going to look at how we can use the t-test function in Excel to get the p-value from a t-test given a sample. So much like with the z-test, this is designed for working on samples, which means we need to put in our sample data. I'll say that as I'm typing this in, dealing with this for situations where you get statistics is a lot stickier. You need to be able to remake a data set where you have the appropriate mean and standard deviation, which is a bit more complicated than just putting in a bunch of copies of the same thing, because that wouldn't have the appropriate amount of variation. But this is really what it's meant for, is dealing with data. But the problem is here as well that this type of test is also meant for working with a two-sample situation, and that's something we'll see more of in Chapter 8, but the way to work around it in this case is to put in the mean we're comparing it to twice. And I'm not entirely sure why it needs to be put in there twice. It's a syntax thing with how Excel runs this. I think it's because you need a mean on both sides and it doesn't like getting the mean of a single value. But anyway, we need to put in that 42 two times to make sure that it treats it as an entire data set. Then we're going to go over to another cell, run equals t.test, and I'll say that the t-test function, for whatever reason, is designed for left tails naturally, or two tails in a way that we'll see in a second. But here, we're going to open up our parenthesis, put in our array of actual data first. Then, in the second entry, we'll put in our fake array of means. Then from there, we are going to indicate whether we're doing one or two tails. If we do one tail, it's looking for a less than or an up to. If we do two tails, it's looking for two tails. So we're going to select option 2 for two tails. And then from here, because it's expecting to work with two data sets and we're kind of tricking it, we don't want to deal with paired things and we're not assuming equal variance. We're going to pick option 3, which basically says these are completely separate data sets. Don't worry too much about that for right now. And for these problems, it's always going to be option 3, but we'll see more about what these terms mean when we get to Chapter 8. Anyway, you put that information in there, you run the computation, and you'll see that we get the p-value that we would expect whether we do this in the calculator or by hand with the table. Whatever works, we get the value we should expect here, where again, much like with the z-test, it's important to understand that all we get is a p-value. So that means we still have to make some form of determination for ourselves about whether or not we reject this in terms of alpha, and also bear in mind the greater context that this is a part of. But just for the sake of computation, this is how you can get Excel to give you that value using one of its built-in functions.